But like I said, those are kind of contrived equations involving exponentials that you can factor. That doesn't happen in very many real life situations. Similarly, we have some logarithmic equations that are also kind of contrived. So they say, for example, consider the equation log base 2 of 2 plus log base 2 of 3x minus 5 equals 3. I can't really come up with any real life situations where that's the starting equation that you'd want to solve, but we can still solve those things. And the idea is, again, if you want to get rid of a logarithm, you kind of put it in the exponent of something, and as those are inverse functions, that would eliminate the logarithm. But in order to apply that, you have to change this two logarithm terms into a single logarithm. You have to combine it into a single logarithm, and then you can exponentiate or change it to the exponential form and get rid of the logarithm. So how do you combine that logarithm into a single logarithm? As long as they have the same base, and in this case they're both base 2, that's the sum of two logarithms. That's equal to the logarithm of the product of the terms. So that's the logarithm of 2 times 3x minus 5, which is 3. And then they simplify the inside, and then from here to here, they're just applying the transformation from a logarithm form to an exponential form. Both sides have base of 2, so that means the base to the third power is equal to 6x minus 10. And 2 to the third power, we know an answer for that, that's 8. And so we get 8 equals 6x minus 10, and we can solve. So another example they had in one of the homework problems was this expression, that horrible thing. And so what you need to do is combine things into a single logarithm. And you can think about it as a single logarithm on each side, like I've done. And then once I get that, to get rid of that logarithm, you can imagine, whoops, that shouldn't be, you can imagine raising both sides to the 10 as an exponent of 10. So putting both sides in a power of 10. And that essentially gets rid of the logarithm. And 3x minus 2 over 2 equals x plus 4. And then you could just solve by normal algebra, right? So 3x minus 2 equals 2x plus 8. X equals 10. And you'd have that. Right, so if you went back to the original equation, you should go back to the original equation and plug that in and see that log of 3 times 10 minus 2 minus log of 2 equals log of 10 plus 4. I plugged that into the original, way back in the original equation. And when I do that, let me give some space here. When I do that, I get the log of 28 minus the log of 2 equals the log of 14. Is that right? That's correct because of the, when I subtract logarithms, those combine to give me the log of 28 over 2 equals the log of 14. And sure enough, that checks out. One thing to watch for is sometimes you get fake solutions. If you solve this, if we had solved this algebra at this point here, and we ended up, say, with x equals negative 10, somehow the algebra came out to be x equals negative 10. When we plugged that back in, if we had gotten in here, say, log of a negative number, the domain of logarithms is only positive numbers. We've talked about that since the range of exponentials is only positive. So in this case, that would not be an actual solution. It wouldn't be in the domain of the original equation. And so that's just one little trick that you have to look for in these logarithm forms. When you solve for a solution, make sure it actually is a legitimate solution in the original problem and you don't end up with a logarithm of a negative number. Just like we had done before with square roots, when you solve, make sure you don't end up with a square root of a negative number. That's also not in the domain and not a valid solution. So I wanted to go over those problems and talk about those specific examples. They're described in the book as well, and there's some homework problems on those. But like I said in class, I want to focus a lot more on the real world situation problems where you have to use the properties of logarithms to solve. And those are more standard like I did in the other video and in class. So hope that helps.